The question is, if a sector of a circle has an arc length of 2 pi inches and an area of 6 pi square inches, the question will be solve for the length of circle's radius. So this question is basically to solve the circle's radius, which means the radius of our circle. And in order to solve for it, they gave us few informations for it, and the first information is the relationship between a sector and the circle. So they gave us the arc lengths of the sector in our circle, which means the sector can be the part of our circle. So the sector can be a part of our circle, and they also gave us the area of our sector. So in order to solve for this question, we can visually prove what we need to do before we solve for this question. And the first thing that we're gonna do is, the first thing is that we know that there is a circle right over here, and there is part of our sector, the thing that is shaded or enclosed by the blue marks, that will gonna be the sector in the same circle. And we need to use our properties. Properties of our sectors to visually prove what the difference or the similarities between the sector and our circle are going to be. And our ultimate question in this case will be solve for a circle's radius. And what is the radius? If there is a big diameter, the diameter that ends from the point on the circle to the another point, this will gonna be what we call as the diameter. This is what the diameter will gonna be, and obviously there will be a origin. We can see central point in our circle, which divides this and this length into half. When the central angle or the central point divides into half, the definition of the radius will be defined in this way. The one of our central point to the another point in our circle, we will call this as the radius, and we will note it as the R as the first letter in our radius. And it is 1 over 2, which means a half of our diameter. So our R value will be the question that we need to solve in our through our diameter of our circle. So the first thing that we need to do in order to solve for this question is we need to think about the formulas to define the arc lengths as well as the area of our sector, which is going to be right over here, the properties of the sector right over here that can help us to solve for the radius of our circle. So the first thing that we're going to do is the arc lengths and the area of the sector as well as its definition. First thing that we need to talk about is the definition of our sector. And as we can see, sector has a specific relationship with our circle on the coordinate plane in our trigonometric functions, because the sector is a thing that was originated from our circle. So the definition of our sector will be the area enclosed by the 2 radii and the length of the arc. And there are 2 more definition or words we need to know in order to think about the definition of our sector. And the first thing will be, what is the 2 radii? And we never saw the word radii, and it is a plural form of our radius. And what is the radius? It is a line that is 1 over half of our diameter. And what is the diameter? It is a line that leads from the point on our circle to the another point in our circle. So this is what the radius means, and it's plural form, which means more than 2 of them. We will write it as the radii, and they wrote the specific letters as 2. So the area that is enclosed by 2 radii, and we can simply prove it visually. So this is clearly formed by a 2 radii, which means 2 radius. This is 1, and this is 2. But we still have our 1 more left, which will going to be our lengths right over here. And they were going to probably give us the definition through the definition of our sector. And according to the definition of our sector, it says, and a length of our arc value. What is our arc value? Arc value literally means this is a line that holds from the point to the point of our radius in our circle, or as well as the sector. And that, if we make a curved line, or you can see that is part of a parabola, we're gonna get a arc length. So we'll call this length as the length of our arc. So this is an arc length, and the area enclosed by two radiuses, and our length of our arc value will going to be a sector. And this is the main reason why the sector has similarities between the circle, and it's because of its formation. And this was the definition of our sector, and the next thing that we need to talk about will be the arc length and the area of the sector's formula. We're going to talk about the formulas of our arc area of sectors, and before we thought about it, we need to think about two more definition, the definition of our arc in our sector. So for the definition, which means the promise between the mathematician did to our definition of our sectors, arc lengths. In our sector, like the circle, the definition of our arc lengths in our sector will going to be, definition of the arc length will be the part of our circumference. And what is our circumference? Circumference will be the full length of our arc lengths in our sector. And if you don't understand what the circumference and every single formula that we're going to do about the sector and the similarities between the circle, you can go back to the 2-1, the first video about the solving for the arc length, the area, as well as the full similarities between the circle and the sector. So the definition of our arc length was the part of our circumference, which is the full length of our radii, and the line between the two radii. And what is the point of the end point? It will going to be right over here, and as they meet together, it will be a curved line that will going to form a arc length. And this is what the arc length's definition will going to be. And for the formula for our arc length, it will obviously going to be originated from our definition, as well as the formula for our circumference of our circle. And what is our formula for solving for a circumference? It is 2 pi r, and 2 pi r will be the circumference. So 2 pi r will be the circumference of our circle. And the formula for our exact arc length will be 2 pi r is equal to circumference of our circle. So the formula will be 2 pi r, so we will just note it as our arc length, is our L value. So our L will be our arc length. And if the L is our arc length, if you assume that the L is our arc length, L value will be 2 pi r times x degrees over 360 degrees. This is what the formula for our arc length will going to be. So L is equal to 2 pi r times x degrees over 360 degrees. This is our definition, and the formula of our arc length of our circle. And now let's go to the next step, where we need to talk about the area of our sector. And the area of a sector is also originated from the area formula of our area of our circle. And for the area of our sector, the area of the sector's formula will going to be, we know that the area of our circle times proportions. Circle times specific proportions of angle. This will going to be give us what gives us the area for our sector. The area of our circle times proportions of our angle that gives us the formula for our sector. So our area of our sector was was pi r squared. But we add our data, which shows that it is a specific variable in our angle, and times all of them times it should be not times, it should be divided by, or you can say times 1/2 pi. This is what the area of our sector will going to be. And if we even simplify this even more, it will going to be 1/2 r squared data, and our 1/r squared data was originated from the area of sector and the circle. So this was the area of our circle and the differences between the area of the sector. So 1/2 times r squared data was our area of our sector, and why was it originated from our area of our circle. And our area of our circle was pi r squared, but it shows the differences between the proportions of our angle into our arc lengths and the area of our sector and the circle. So if you go back to our original question, they said that the properties and the similarities between the sector and the circle. And this includes our first one, where we talked about the formulas to define the arc lengths and the area of our sector. So the last thing we need to talk about is our radian measures. The radius of our circle and the radian measures. And we obviously talked about the radius of our circle if you go back to our radian measures. And we know the methods to express the angle size, the size of our angles, is firstly the radian measures. And our common or the usual fact that we use our degree mode to define an angle. But we use our radian measures in the trigonometric function systems about the radian measures, and what it does is the radian converts the angle. It converts the angle into the real numbers. This is what it is to be the radian measures. The radian converts angle into real numbers, and that is the main difference between the radian measures and the degree measures. For the degree measures, we use our degree signs to show that what the angle will look like, but that is not a real number. That is just a one of the methods to express the degree mode. But for the radian measure, that is a method that converts our angle into our real number forms. And our most popular example will be what is the 360 degrees in our radian measure. Well, it will going to be 2 pi. And from this 360 degrees is equal to 2 pi, we might be able to solve for every single radian measures in our trigonometric function systems. And what is our 180 degrees? What is 180 degrees? Well, we know the 180 degrees is 2 times less than 360 degrees. So we also need to do times 1/2 to our 2 pi, which we're going to be pi radians. And this is what the examples of our radians will going to be. And the radians is also crucial when it comes to solving for the trigonometric function systems, because without it, we won't be able to solve for the actual sines or cosine as well as tangent graph, which is the most important thing in our function system. So if we go back to our original question, try to solve for it. The given information is that the sector of the circle has an arc length of 2 pi. So let's say this is a sector, so we can we'll be able to bring this copy and paste this right over here to see what the sector according to our information will be given like. So let's say there is a sector that looks something like this. And let's erase the properties as well as the arc signs to make it clear about this. And if this is an arc length, if this is a sector, the first thing that we're going to talk about is what is the area. What is the area of our sector? The area of our sector will going to be 2 pi square inches. So 6 pi square inches. And what was the formula for our area? The formula for our area of our sector was pi r squared theta times 1 over 2 pi, which was 1 over 2 r squared theta. 1 over 2 times r squared theta, and that is equal to 6 pi square inches. Now let's go to the second one, and the second one will be what is our arc length of our sector. The arc length of our sector is going to be 2 pi, according to 2 pi inches, according to the information through our question. And what is the formula for it? The formula for our arc length will be the L value, which we're going to note it as our arc value, will be 2 pi r times x degrees over 360 degrees. And this satisfies our arc length answer, which we're going to be 2 pi inches. So using this value, we'll be able to solve for the what is the radius, which is what is the radius? The radius is a value that is exactly half of our diameter, which is the line that connects the point to point on the circle. So what does the radius stands for in our formulas? The radius stands for the r in our every single formula in our area and the arc length of our sector. So sum the arc length in our area and apply it to our sector. This arc length is what the 2 pi inches will going to be, in our area of our total formation of our sector will be 6 pi square inches. So using these informations, we'll be able to solve for other the r value using other informations. And if you write this again, it will going to be 2 pi r times x degrees over 360 degrees will be 2 pi. And so this is what the 2 pi will going to be, and this will going to be what the arc length is going to be. The area of our sector with the formula is going to be 6 pi inches, which is 1 over 2 r squared. Theta is equal to 6 pi square inches. What would happen if we divide 1 over 2 r squared? Theta is equal to 6 pi squared. It is in specific format, or simplify this even more. So that means 6 pi, which is our original form instead of square, because square is a total area and we're trying to solve for the value before the area. And this 6 pi is equal to 1 over 2 r squared theta. And what is 1 over r squared theta? That is same thing with 1 over 2 r times r theta. And that is equal to 1 over 2 r times 2 pi, because r theta is what 2 times pi will going to be. So r times theta radius times the central angle is going to be the 2 pi. And according to its property, 1 over 2 times r times 2 pi is what 6 pi is going to be. And in order to solve for the r value, all you have to do is divide all of this by 2 pi. Divide all of this by 2 pi. And we'll get 2 pi, and the 2 pi will be erased. and this will going to be 1 over 2 r, that is equal to 3. And in order to isolate our r term, all we have to do is times 2 to the both side. And if we multiply 2 to the both side, we will get 6 r, which is our radius that we were looking for, will be 3 times 2, which is our 6. So our radius in this case will be 6. So our answer for this question will be 6 or 6 inches if you want to add a unit to it.